Alright guys, Mrs. Johnson here. Hope you're having a good snow day / cold day. Hope you're staying warm. Let's see, these are the notes from our packet. So if you want to watch this on your actual computer since you're at home and take notes into your iPad, that would be fine. That'd probably be my suggestion so you have notes for this page. But we're doing 4.2 exponential functions. So just as a warm up here, what we're going to do is try and figure out if we can write these expressions as a base to an exponent. So basically you're just trying to figure out what this is with an exponent. So you know that 9 is 3 squared. So that's kind of what we're trying to do here. 125 is 5 to the third. 1 over 27, well I know that you know 27 is 3 to the third. So keep in mind you can also write that with a negative exponent. That would be 3 to the negative 3. Okay, and then 1 over 6, even though 6 is not a perfect square, you can still write it with an exponent. It would just be 6 to the negative 1. Okay, so just kind of as a warm-up and something to think about, that's what we're going to be using to solve these exponential equations now. So exponential equations, what that means is the x's are in the exponents, like the first example that you're given. So what we're going to try and do is implement what we just talked about in the warm-up. So I know that I can write 125 as 5 to the third. And then just keep the exponent that's already there, x plus 1. So I'm just rewriting these as bases with 5s. And 25 you know is 5 squared. And then just keep the x exponent that's already there. Okay, so now that we have a 5 on each side, you know that the exponents are equal. Okay, so the whole purpose of that is to rewrite those so that they have the same base. And once they have that, you can just equal the exponents together. So that means that 3 parentheses x plus 1 equals 2x, so distribute your 3, and then just solve for x. That means x equals negative 3. Okay, so pretty simple first thing to be talking about here is just getting the bases to be the same on each side, and then you equal the exponents together. So a couple more examples that get a little bit trickier. Let me zoom in here. This one's not too bad. 64. I know it's 8 squared, but 8 you can't write as 4. And so the 8's not going to help us. But 64 actually also is 4 to the 3. Did you know that? And then we have 4 to the x minus 2. So again, now that they have a 4 on each side, what we can do is just equal the exponents together. That means that 3x equals x minus 2. 2x equals negative 2. X equals negative 1. Did you also know that you could check these? So they're equations, right? So if you're not sure or if you want to make sure that you did your work correctly, so you're just plugging in negative 1 into the original equation. Is 64 to the negative 1 equal to 4 to the negative 1 minus 2? That's what you're doing. So is 1 over 64 equal to 4 to the negative 3? Well, 1 over 64 is 1 over 4 to the third, which is 1 over 64. Okay, so all these are checkable. You don't have to go through your work and check them every single time, but if you're unsure or if you want to be sure, then just use your calculator, check your work, and make sure that you're good. Okay, let's go over to this one, number 2. So radical 3, you know that you can write that as 3 to the 1/2. We talked a little bit, we refreshed our memory on that yesterday. Remember, 1/2 exponent means square root. So then you know that 9 is 3 squared, and then just, again, keep the x that's there. And now we have 3's on both sides, so you can equal your exponents together. So 1/2 x minus 2 equals 2x. Distribute the 1/2. Actually, I think what I'll do is clear the fractions. That might be easier. I'm going to multiply everything by 2. That gives me x minus 2 equals 4x. There we go, that's easier. Negative 2 equals 3x. X equals negative 2/3. Again, you can check those answers in your original equation with your calculator if you need to. We're just trying to get x by itself. Let's go over to number 3. 1/3, if I want to write it as a power of 3, I know it's 3 to the negative 1. And then keep the 2k that's already there. And 9 is 3 squared. So now that I have a 3 on each side, I know that the exponents are equal to each other. So I have negative 2k equals 2, k equals negative 1. I feel like negative 1 has been an answer for a lot of these. Oh well. And number 4, 1 over 9. So you know that's 1 over 3 squared, or 3 to the negative 2. And that equals x to the negative 2. So this one's a little bit different just because the x is one of the bases here. But if you look at what we have, our exponents are equal. So if the exponents are equal, then that in turn means that the bases have to be equal. So kind of a weird question, but that just means that 3 equals x. Okay. There's a couple more of these that we can do, and I want to get you used to using e again. So if you remember, e is this decimal here. It's kind of like pi, and we're going to be using it a ton this chapter. This is the chapter where e comes really big into play. So let's pretend like it's just a normal variable, and you know that it stands for something, but we're going to treat it like it's just a variable in this case. So we have the bases are the same on each side, so that means that my exponents are equal to each other. So 4x minus 1 equals 2x. Just like if it was a 3 or a 2 or any of the problems that we did earlier. That means that 2x equals 1, x equals 1/2. So don't be freaked out by the e. We're just treating it like it's a normal variable or number for that case. Same thing here. I know I can rewrite this as e to the negative 3 because it's a fraction, and then just keep the k minus 2. And this side is e to the 2k plus 5. So I have an e on each side, which means equal the exponents together. 2k plus 5 equals negative 3k plus 6. Be careful distributing your negative there. You end up with 5k on this side, 1 on that side. Be careful in your dividing. It's 1/5, not just 5. Okay? Last one for this case. Again, I have negative exponents that I can use here, so this will become e to the negative 1 to the negative 3x. And this will become e to the negative 5 to the x minus 1. Again, now I have an e on each side, which means just equal the exponents together. So when I multiply the negative 1 times the negative 3, I get 3x. I distribute my negative 5 on the other side very carefully. Negative 5x plus 5. Add the 5x over. And that means that x equals 5 over 8. Okay, so we do the same thing with these, basically. But remember, that's going to come into play big time once we start doing our logs, which is happening tomorrow, so get pumped. All right. Let me zoom back out here. Solving equations. The important part here about our solving equations is to remember to have a plus or minus if we take an even root. And we also need to check answers for extraneous solutions when we're solving these equations. So just FYI, if we look at this very first example here, what I like to do is get rid of the denominator. Whoops, I'm making straight lines here. I like to get rid of the denominator first. So what I'm going to do, zoom in here, to clear that 3, I'm going to raise both sides to the third. And do you see how if I raise 2/3 to the third, you know how you have to multiply the exponents there, so that's going to just give me r squared on this side. The 3's are going to cancel. And then on the other side I have 9 to the third, which is a huge number. I'm going to leave it as 9 to the third. You could use your calculator, but to make it a little bit easier, what I'm going to do is just leave it into that as that exponent for a second. And now you can see that to get r by itself, we need to square root both sides. And when you square root both sides, you know you need a plus or minus in your answer. R equals plus or minus, and that's because this is an even root. It's a square root. That's what I underlined above. So if you remember how to do these problems when you have a square root and an exponent, it's way easier to actually square root the number first and then raise it to the third, make it smaller before you make it bigger. So what I'm going to do is make that 3 to the third, and plus or minus 3 to the third is plus or minus 27. So we have 2 answers for this. What I'm going to do is check both of those. So if I check 27, I'm going to do 27 to the 2/3. Is that equal to 9? Question mark. I'm checking it in the original equation, just plugging in the 27 for r. So remember, 27 to the 2/3 means the cube root of 27 squared. Well, you know that the cube root of 27 is 3 squared is 9. So positive 27 works. Okay, so do the same thing with negative 27 to the 2/3. Is that equal 9? Well, you know if you translate it, you get negative 3. And then when you square that negative 3, it's going to become positive 9. So yeah, that one works too. Remember, you can cube root negative numbers. When you cube root negative 27, you get negative 3. But then you have to square that, so you get 9. I guess I should have parentheses around this, because I'm raising that entire number to the 2/3, not just the 27. That was actually pretty important. Okay. Good. So let's do one more of these. Again, the first thing that I like to do for these problems is to raise it to the 4th to clear the denominator. And that's going to be an enormous number, so I'm not actually going to multiply it all out, but you know those 4's for the z cancel, so that gives me z to the 3rd equals 27 to the 4th. Okay, so to get z by itself, you know that you have to take the cube root of both sides. And remember, when you take the cube root, you do not need a plus or minus, because it's a cubed root. Okay, just be careful about that. So that's just going to give me z on the left. And then I'm going to do the cube root of 27 first, which is 3, to the 4th, which is 81. Okay, so I'm going to check that real quick. I'm going to do 81 to the 3/4. Is that equal to 27? Question mark. So remember what we learned about rational exponents. That means that you turn it into a radical. So it's the 4th root of 81 to the 3rd. Is that equal to 27? Question mark. Well, the 4th root of 81 is 3 to the 3rd. Actually is 27. Yes. So there are occasionally some extraneous solutions for these problems, so just beware of those, okay? All right, last problems. My dad is a financial advisor, and he uses this formula every single day when he invests people's money. Okay, this is super real life application stuff coming at you here. This formula, if you ever put money into a bank and they calculate interest, which some of you probably already do have money in banks, some of you will eventually. I wrote up here, mo money, mo problems, although sometimes that's not always true. Okay, we need to figure out, here's this formula, and by the way, you need to memorize this formula. This formula will not be given. Maybe some of you have seen it before, but it needs to be memorized. I need to let you know what all of this stuff actually means, all the letters in the formula. And then we'll just, it's really just plug into your calculator. You just need to know the formula. So A, first of all, is the amount of money you end with. A for amount. Okay, P is the initial amount, or starting. That is not spelled initial. Hold the phone. I-N-I-T. Amount. It's actually used a letter P because if you've ever seen the word principal before, principal means starting amount, or like the amount of money that you put into the bank when you're talking investments and money and that kind of things. Maybe some of you have heard the word principal. That's why it's P. Okay, R is the rate, which is a percent, but you need to change it to a decimal. Be very, very clear and make sure that you change the rate to a decimal, because it has to be a decimal that goes into the formula, just FYI. We've done other problems where you have to change percentages to decimal, and it's the same thing here. All right, N is the number of times the money is compounded per year. Okay, that's kind of like the hard one because we need to talk about all these different n's that could be given to you in the problems. And then T is just number of years. Okay, so there's a lot of variables in all of these problems. I want to talk to you about some really common ends for a second. So if it means number of times per year, then some of the problems will say the interest is compounded daily. So think about how many times per year if they mess with your money daily. That means that n equals 365 because there are 365 days in each year. Okay, what if they mess with your money weekly? Well, how many times per year is that? That means that n equals 52 because there are 52 weeks in a year. Another one would be monthly. I feel like you probably get the hint, but that means n equals 12 because there's 12 months per year. One that's pretty common that a lot of you might not know what it means, semi-annually. So semi means half. So every half of a year, they compound your interest, which means n equals 2. That means that your interest is compounded twice a year. Semi-annually means every half of a year, which means it happens twice over the course of a year. I'm trying to think if there are any other ones. Oh, quarterly, duh. So if they compound your interest every quarter, that means it happens 4 times per year because there are 4 quarters in a year. Okay, so those are some pretty common ones. So those are the n values that you're going to use in the formula. And then just beware, this formula up here, the one that you need to have memorized, yes, there are 2 n's. Do you see that? There's one there, and there's one in the exponent. So yeah, you are going to use the n twice, so it's super important within the formula. Okay? That's what all this stuff means, so let's do these 3 problems. If you have a graphing calculator, you'll be able to just type all of these numbers into your calculator all at once. If you have a scientific calculator, I don't know if it can handle all these numbers at once, so you're going to need to remember your order of operations. Okay, so find the balance of $4,000 invested. What this means is this 4,000 is our P, that's our starting amount or our principal amount. And it's invested in the bank for 10 years, that's our number of years, that's our T. Paying 5.75%. That's the rate, but you have to change it to a decimal really carefully. Remember, you have to move the decimal twice to the left. So it's actually 0.0575. I see a ton of mistakes in just changing decimals, so be careful with that. And compounded quarterly. That means that our n is 4 because quarterly means 4 times per year. Okay, so if we use the formula that's up above, I'm not sure, yeah, we can see it there. Okay, so it's asking us to find the balance, or find the amount of money that you end up with after all this time. So A equals, the P is the 4,000, and then in the formula it's 1 plus, and the rate is 0.0575, over N, the N was quarterly, so it was 4, and then to the 4 times 10. Because the number of years is 10. So this is what I want to see on your work. This is the numbers that I want to see plugged in. If you have a graphing calculator, you should be able to type it in with the parentheses exactly the way you see it, and you'll probably have to, I would just make this 40. Because 4 times 10 is 40 when you do your exponent. However, if you have a scientific calculator, you have to remember order of operations, so don't forget your PEMDAS. Okay, parentheses, exponents, multiply, divide, add, subtract, which means that the parentheses have to come first. And when you do those parentheses, I'm going to write this all out for this problem, and then you guys can do it in your calculator and just check your answers for the next 2. So yeah, I'm going to do 4,000. Just for that parentheses part, I get 1.014375 to the 40. And so then after you do that, what comes after parentheses? Exponents. So you have to raise that tiny number in your calculator to the 40. Basically, you multiply by the 4,000 the last thing you do. Okay, so that number to the 40th is, I'm going to write it over here. So now we're at 4,000 times 1.76, 987-ish. And then very, very last thing you do is multiply by the 4,000. So we end up with a grand total of $70.79 or 70, wow, I said that backwards. 7,000, leave me alone. $7,079.48. So I know that in our class we always round to 3 decimal places, but people, this is money. So let's be like money conscious, and we round to 2 decimal places when it is money. So if you want to type that whole thing in your graphing calculator all at once and see if you can get that exact answer, but it does need to be very, very exact. If you're off by a penny, I think that's okay. But think about your investment in your insurance brokers and your financial advisors. They are going to be pretty upset with you if you're off by more than just a penny. Okay, so you need to be very, very accurate on your calculations here. Let's try number 2. What I'm going to do for number 2 is go ahead and get that problem set up. I want to have $15,000 in 10 years. So you have to read really carefully. This doesn't mean that you're putting $15,000 into the bank. It means you want to buy a car and it costs $15,000, and that's the amount of money you need to have at the end of all of this. So that's going to be what my equation is equal to. 15,000 is my amount. How much should I invest now? What should my principal be? That's what we're going to be solving for in this problem. You have to read super carefully. So 1 plus, the rate is 0.0275 when you change it to a decimal. Compounded monthly. Monthly means the n is 12. And I have it to the 12 times the number of years again is 10. So here's all of my numbers plugged in. What you need to do is do your parentheses first. And when you do that, you end up with 1 point, let me write this all out, 15000, 1.0022916 to the 120. So now what comes next is the exponent, so you're just going to raise that to the 120th power. So we still have 15,000 equals p times 1.31611. So showing all of your work, this one's a little bit harder to do in the graphing calc all at once, so I would recommend kind of doing it one step at a time. So now you need to take your 15,000 and divide by that answer. Divide by the 1.31611. And we end up with our starting amount, which you know should be less than what you're ending up with. So use a little bit of common sense here because you're not putting in as much as you end up with at the end. 11,397. I got 0.17 if you round up. Okay, so be really careful and pay close attention to whether or not you're starting with your A amount or if you're starting with your P amount. Just be aware of those. Okay guys, last problem and then I'll leave you alone. Compounding continuously. So if you read through this problem, it doesn't tell you what your n should be. So that means that you can't use a formula that has an n in it. It asks for how much money you'll have in your account, 5 years, there's the rate, there's the principal. It doesn't tell you when, how many times a year it's compounded. It doesn't say monthly or weekly or daily or semi-annually or anything like that. So when it says the word continuously, that means that you need to use this formula. I like to call it the PERT formula. Okay, and E is going to come into play. Remember, E is 2.718. And most of your calculators will probably have an E button, just like they have a pi button, and that's even more accurate than just using the decimal. Okay, so it works the same way with all the variables and everything, except it's a little bit easier to use because there's no n. Alright, so it says how much money will be in an account, so I need to know what the A is. I put in $1,000, that's my P. E is that decimal, or it's a button in your calculator, and the rate is 5%, which, be careful, means 0.05, and T is 5 years. So you should be able to type this into your calculator all at once. And once you crunch that number, 1000e to the, I would probably put parentheses around this exponent so it knows that both of those numbers are in the exponent when you type it. You could also use 2.718 for e, but if you just type it all at once, your calculator should be fine. That gives you $1,284.03-ish cents, 0.25. So again, if you put in $1,000, if they compound it continuously, anytime you see the word continuously means use that formula, okay? P-E-R-T, P-E to the R-T. That one needs to be memorized as well, but that one's pretty easy to memorize, okay? That's it. Math Excel homework, I think it's 10 or 11 questions. It's some of the exponential equation solving ones, and then also some of these money problems. So get it done. Proud of you guys for doing some work on your snow day. Hopefully this video isn't too long for you, but I think you're going to do a great job. Email me if you have questions, and hopefully I'll see you tomorrow.